Hello everyone. In this video, we're going to talk about how we have how to take something we have already done in Gazebo, that is setting up your ROS to control, say for bicycle ceiling controller, and then how you can use the same setup but just change the interface from Gazebo to Isaac Sim. So, what are the plugins you have to change? How the URDF will change, and what are some additional packages you need to download, um, and what do you have to change in your launch file. So we're going to talk about that, and we're also going to talk about how you're going to set up your action graphs on Isaac Sim so that you would be able to communicate from Isaac Sim to ROS2 and vice versa. So let's get started. As you see, it's the same workspace I'm going to work on, which we did for Gazebo. I'm only going to highlight what I changed for it to work on Isaac Sim. As you can see here, first thing what I changed was the URDF. So in the URDF, what you see here is basically I have changed how the ROS2 control interacts with Isaac Sim. So initially we had ROS2 control interacting with the Gazebo system. So the things I have changed here is that instead of the plugin we used here, which is Gazebo ROS2 control, we use another plugin called topic based ROS2 control, and this would give us direct join topics and join state topics, which we can refer from inside Isaac Sim. So this is a package you would need to download for us to get this working. So in the URDF file, what we change here is that we put this plugin called topic based ROS2 control and then slash topic based system. And this is the plugin we have to use instead of the Gazebo one. And then these are going to change as well. You're going to have the parameter name as joint commands topic slash Isaac joint commands, and then for joint state topic you have Isaac joint states. So this two params are going to help you to map the commanded joint values and the current joint states to these two respective topics, which we are going to refer inside Isaac Sim. And also you're going to have these additional parameters, which are just going to just say the publishing rate and some joint states. And the next thing is, once you have set up this one, this is just going to set up Isaac like the topic based ROS2 control. Next, you're going to say which are the joints you're going to be using these setup for. So for us, we would be interested in the steering and the rear wheel because it's a bicycle steering controller, as we have talked in the previous video on the Gazebo thing. So you would set up a joint name as the front steer, which is the steering, and then you would set up the command interface name as position and command interface name as velocity. So you would basically give both position and velocity, and then the state interface you give position and velocity. So this is one thing I observed, that you have to have these two kind of similar for it to for us to have a final control on whether we are controlling the position velocity by giving everything, exactly uh, which ones to take from the array of values you get on the Isaac side. So you put the command interface as position and command interface name velocity, same for the rear wheel as well. So once you have done this, it should be uh, enough for us to control, to know that what it's going to publish. And then this is also useful to get the topic based ROS2 control to do the publishing, to be the interface between ROS2 control and Isaac Sim. um, the next thing what we have to do is to work on topic based ROS2 control. So topic based ROS2 control, um, so the next thing is to have topic-based ROS2 control. This is going to be the interface between your ROS2 control and Isaac Sim. So all you have to do is to get clone this package into your workspace, because we need to modify certain things in this package. So we clone the whole source code into your package. Once you clone it, you would see something like this inside your workspace, and you would have to do a small modification, that is, in the line 276 you would just comment out this line. And this has to be done because you want the joint position values to be updated every time. You don't want, the logic here is it only updates when there is a trigger in velocity threshold. So you don't want that to happen in your case. So this is a small modification you need to do on this for it to work, for the bicycle steering controller to work. So once you do that, then the other changes would be to just modify your launch files you had initially to just not include um, Gazebo in the launching. So I just commented out this portion, which was to include the launch file for Gazebo. This was basically spawning the robot in Gazebo environment. We don't want that to happen because we already have it spawned in Isaac. And apart from that, everything else remains the same. For example, your config file is the same. You don't have to change anything. It's all based on the robot details. So these things would be the same. And make sure this matches with what you have defined in your URDF. And also the launch files you have already defined for launching the controller remains the same. um, and yeah, everything else remains the same. These are the only things you would have to change on your code for things to work. So let's take a deeper look at the action graph. So here we're going to talk a little bit more about the action graph. And in the action graph, you can see um, the overall flow of all the different nodes we have to set up for communicating with an external ROS2 controller. And here you can see the two articulation controller we talked about in the last video, where you use it to move the Cocoon Express. Here there are some more extra nodes we added over here to enable to subscribe from a ROS node and also to publish to a ROS node. So let's go in detail of each of them. So first talk about the on playback ticks. So this is the basic execution ticks which we give in Isaac Sim, and also we use Isaac read simulation time. This is needed because we want to publish the simulation time, and we want to have the sync between the joint states we are publishing, the timestamps, what we're using for that, and also the timestamps which ROS2 is publishing. So we want to have those two match. So we're going to use the read simulation time, and we use ROS2 context whenever we deal with ROS2 on Isaac Sim. And here you can see that we are publishing this simulation time here. We're using this and we're sub publishing it to the clock topic on ROS2. So in this way, we have one particular time as a reference, and um, we can use that to publish from Isaac Sim, and also that same clock is used internally by ROS2 to publish the join state commands. And the next off would be um, talking about two different, one is the publisher and another one is the ROS2 subscriber. So because we set up Isaac Sim joint state topics and joint control topics for, if you remember, we have to listen to them and we have to also publish to them. For example, you can take for the subscribe, we have the ROS2 controller running at the back, and that is constantly publishing to the Isaac joint commands, which you can see here. That's how we set up the plugin to work, and that's the same name we are going to use here to get the joint values. Um, and similarly, we want to publish what the state of the robot is from here. So we use Isaac joint states. So we are going to use the same topic name we defined in the plugin, and this is the place where that connection happens between ROS2 control and Isaac Sim. For in order to publish the exact joint states over here, what we do is we use the articulation state. The articulation state gives you the joint values at that particular time. So if you take articulation state here and we just take the corresponding um, joint names, and the two things which we are interested on is the rear wheel and the front steer. So this order is important as to match how you define your the plugin part of the URDF, so it has to match that. And here also it goes a little bit in detail into like header stamp, the timestamps. So I use Isaac time splitter so to get like nanosecond and second level detail. So we use that here. And the articulation state, there's two different states we are interested in. One is the push in and then the other one is the velocity. So we connect them here, and then we use ROS2 context over here, and then we use on playback ticks to execute it every single tick. So in this way we are publishing um, to the joint state topic. So you can define the topic name to where you want to publish, and then you are also defining the type of message. So you're defining joint state. So if you see, for every message there is a naming convention. So you would define that same naming convention. If you just hover over it, it'll tell you how this works. So message name would be the last part of that path, and then this would be the this would be like standard message. It would be the first part, and then this one would be the middle part of that whole path. So just hover over this and then you'll know how exactly you have to fill in these things. So it's used to specify what type of message you're using, what type of message in ROS2 are you using to communicate. um, for subscription you would do similar, uh, uh, you would work similarly. So you would define the topic name here, and you would use ROS2 on playback text and then ROS2 context. Um, and then you would have outputs. For subscribe, you will have outputs here. And The other thing is that uh, you have push in commands and then velocity commands. So this is, you have to take the correct subscription. So this is ROS to subscribe join state. So this is specific for join states. It's not just a common ROS to subscriber, but it's a ROS to subscriber for join state. So if you take this node, you don't have to define the message type. Otherwise, you can use a common one too, and that works. So once you have push in commands and velocity commands from here, then it's similar to the any other video where you control uh, a robot through articulation controllers. So you get push in commands. So here we want to control the steering, and then this is the velocity command. Here we want to control the rear wheel, and you use this push in command, and because the push in command gives you both the front and rear at the same time, and this one also gives the front and rear, um, you would specify which index you want to use. So based on how you have defined this in the URDF structure, you would have say the the joint states, like the push-in commands for the rear first and then the front. So for here, for the push-in, we're interested in the front. So we have this the first index which we're going to use, and for the velocity it would be for the rear wheel, which is the second index, which we're going to use. So it's going to come out in a format such a way that for push-in it talks about um, front, and then it talks about the rear, and similarly it talks about the front and then the rear. So make sure you match that convention how you have defined, and then you would be able to use the articulation controller here. So in this way, you have configured Isaac Sim to talk with a ROS2 controller. Uh, to start off the ROS2 side of things, we go into the working directory. So here is Cocoon workspace, and then you source install setup.bash, and then you give this launch, which we modified previously, and it's still Gazebo, but yeah, this is the one we converted from Gazebo to just work for Isaac Sim. So we launch this, it launches Arvis on the back, don't worry about that, and then you launch the twist converter, which we did in the previous video, which is to just take the teleop command and pass it down to ROS2 control. So we start that, and then we start the twist command. Now you have the twist command. The bottom one is the PID controller. We'll talk about it in the next video, but right now we're not going to go deep in that. So if you press I, it moves forward, and then you can stop by pressing K, or if you press U, you can turn, and then also you can press O, also you can turn, and then you can move any direction. You can even move back. So all the keyboard controls now works. At the background, it is all the controller, ROS2 controller, which is making this happen, and you can see what your subscriber is doing. So your subscriber here is basically getting subscribing to Isaac join states, so Isaac join commands, and then when you are say pressing I, you can see the value being changed here. So this was how we set up the overall ROS2 and Isaac Sim to talk with each other and make the magic happen. That is, use the keyboard to move your robot on Isaac Sim, and you're using ROS2 control at the background. And this is all the changes you need to do from your Gazebo setup to get it to work with Isaac Sim. In the next video, we'll talk about how we implemented a PID controller and how that is interfaced with Isaac Sim as well. Thanks for watching, and subscribe if you want to get the notification for the next video.